Okay, cool. Welcome, everyone. I'm Jesse. I run a company called HashRate, where I try to bring more hash rate to the beautiful continent of Africa. Um, and I'm very bullish on Bitcoin mining in Africa because two fundamental reasons. First of all, there's a lot of energy resources, right? And second of all, there's no strong currencies to paper over the development of them, which means we need Bitcoin in order to enable all of these energy resources to be built and to be transferred into electricity. Okay, I think we're almost there. Right. If you want to follow my YouTube, you can do that with the go right there. That's my website. Bring more hash rate to Africa. Here we go. So today I want to talk to you guys about Project Umfula, which is about 8 hours drive from here. From PE, you can fly and drive 4 hours. It's in the Eastern Cape, and it's based on a South African farm, where it's very, very remote. And so the idea of this is to, and I also have a booth downstairs. The idea of this really is to give people more of an understanding and a grasp of what it takes to mine Bitcoin, right? We all hear about wallets, Lightning, digital, right? Mining is a very real physical part of all of this. And I think it's often not understood or misunderstood what actually secures the system that we love all dearly and use every day, right? So at the end of this, that's kind of what I want you guys to take away, right? What I want you guys to take away. So what does it actually take to build projects? That's the idea, right? So Bitcoin mining being the buyer of last resort, all of these concepts I try to explore on my YouTube channel as well. But at the end of the day, this farm in rural South Africa has two options, right? It can take power from the grid, which has previously shown to be very unreliable, or it can produce power itself. And the first option also comes with a very high cost, right? So the farmers that we are working with, they built their own hydro dam. Okay, so this is a 20-year-old at least dam. Tell me if you can see this. I know the lighting is not the best. What are we working with here? It's not too great. Okay, so I'm going to walk you through this. You have a river coming down here. This is part of the Orange River, which is part of the water transfer scheme, right? That irrigates the Eastern Cape with water, meaning there's low fluctuation in the water levels, right? So there's no high tide or low tide. And these guys built this hydro dam. You have the intake on this side. Down here, you've got 3 turbines that churn, and then you have a control room, which we'll get into just now, and you have a step-up transformer. That's me, that's Albaki, and that's the power going that way to 3 houses on the farm, right? So what they power with this, it's a 40 kilowatt dam, so it can approximately power 12 toasters, right? To give you a perspective, 12 toasters at the same time, maybe 13 if you're lucky and are very efficient. That's what they can power with this. And they power 2 of their pumps, which irrigate their land. They herd cattle there, mainly sheep, and they have to irrigate the land for them to have something to eat, right? And then they have also 3 homesteads, 3 houses, where they obviously need power for all the usual beautiful things. And then, very importantly, they have a ballast here. Okay, and we're going to get into this right now. This is just a closer look. You've got the 3 turbines, 1, 2, 3. They're all connected to a bar that turns. The water goes through and turns. And you've got this beautiful contraption here, which we call an ELC, electronic load controller, which basically controls how much power is going to the grid and how much power is going to this thing over here. We'll get a zoom out picture of this just now as well. I took a picture with my phone and measuring the temperature, you can see this is 250 degrees hot, right? So we're talking significant heat. Like I was standing where my water bottle is over there at that distance, I could feel the heat like this, and it was South African winter, right? So there's significant energy going into this. So we built this mining hut, right? We have 1, 2, 3, 4 times 3, 12 machines over here. That's me inside of it. We built this in Durban with an electrician, right? So we ordered the machines. We built this hut from scratch. We have the cables going in. and all the rest of it. You know, we're not going to go into super much detail, but essentially we've got the machines inside, we've got a router, we've got cable channels, we got the works. And this used to be a cell phone, like under every cell phone tower you find like a box. And we bought one of these boxes. It also had a bullet hole in the top. And then this is the workshop again. So what we built here is essentially a contraption to measure how much power is the existing system sending to this dump load. Okay, and depending on that data that we read here with an Ethernet cable going to the HUD, we can read the electricity, the current that's going through each of the three phases that you can't really see because of the lighting. And based on that data, we then ramp up and down our machines. Okay, so we always make sure that we don't take power from the farmer, which they were very, very adamant about. Like if we cannot run our pumps, you're out of here, right? So we have to make sure that we only take the power that's otherwise sent to this next beautiful contraption. You saw a close-up of that earlier, right? This is basically a set of oven rods that they repurposed into a resistor. Okay, why do they do that? Because the turbine that you saw always needs to run stable at 50 hertz. Okay, you might have heard about this. Who's familiar with what 50 hertz means? Okay, so I'll explain that briefly. Demand, supply, and power always need to be in equilibrium, right? If something runs at 50 hertz, like your laptop, anything electronic, then it means, you know, the system is running stable. Now, this turbine has to be at 50 hertz always, otherwise it'll, figuratively speaking, run down the river, right? And will turn way too quickly and break. And so in order for this turbine, which remember runs on a river that's always on, right? There's no low tide, there's always water, there's always flow, there's always energy. In order for this turbine to get rid of enough power, they send it to this dump load here, basically just creating heat, okay? And that's energy that's wasted, okay? So they consume all of the power on the farm, and then they have extra power that they send to the heater to be turned into heat, just to enable the turbine to run stably and reliably. Yeah, so then what do? We took the HUD to the site, transported it from Durban, probably a day's trip on the back of a truck. And then we installed an internet LTE antenna in order for us to have internet locally. Let me shrink me to it. Yeah, so that's a pole right next to the site, and this is very significant. On the left side, you will see why Bitcoin mining is revolutionary. Because all we need in order for us to be able to turn energy into something of value, to find a customer for the power, is an internet connection like that. Right? Anything else needs a road, needs a pipeline, needs a grid. Those are expensive. So Bitcoin mining in that sense is very revolutionary, because for the first time as humans, we can turn energy into value without the need for that. And it changes everything. Also, of course, these machines are super flexible, right? So we can ramp them up and down as we want to. As I said, right, with the availability of power, we can make sure that we only take the excess and never churn or tap into the power that the farmer needs also. Yeah, that's me. These machines weigh 16 kilos each. That's why you see me flexing. And then, yeah, we have our hut over here. We had some cows running past as well, which is funny. But this, importantly, needs to be protected against heat. So we have like a bit of space up there in between the roof and the hut. It has mesh netting against bugs as well. So there's a lot of things that we need to think about, because these machines don't like dust, right? They don't like bugs flying into them, being sucked into the vents and stuff like that. Cost overview.
Sorry.
Right? Yeah, go ahead.
Sorry, on that point, do you have air conditioning as well in the?
No air conditioning. Too expensive. Also takes too much power away from what we want to use for mining. Right? Yeah, no, there's a vent that makes sure we have fresh air intake, but there's no active cooling of the air. Any idea, rough ballpark, what this project might have cost us to set up? Anybody want to guess? There's a split. You have 30% is cost of the ASICs, and you've got the hash hut along with legal fees and all of that jazz, electrician, labor, parts, and then we have travel and transport. Any takers? 3 million rand? Yeah. 300K. Okay. So to give you an idea, we can make that money back with the site running at 80% uptime in about a year. Okay, so that's how much money these 12 machines will generate. Realistically, when you plan these projects, you want to be very conservative. So it's going to be probably more like 1.5, 2 years.
So
yeah.
So is that 80% runtime and the farmer still taking electricity when he needs it?
Because they built this thing way too big. Right? So a lot of the time the energy will be left over.
Sorry.
Go ahead.
Asking this question while you're talking about how do you control the uptime, downtime?
The magic, right? So there's a little controller in there. I can't go into too much detail of this, but this thing basically says, give me data on how much power you would send to the dump load, and I will turn the miners up and down depending on how much power is available, right? And it'll change the voltages on these machines, and it'll balance out the three phases. It gets very geeky, I'm sorry, but that's how it
is in real time.
Yeah. Well, we have a buffer, but I can go into more detail at the booth here. So that's our revenue right here. So we have number of machines up there is 10 M30S machines. I have 2 examples downstairs if somebody wants to have a look inside of what they look like. Total will be 8,600 terahash, an uptime of 80%. Who knows what hash price is? Show of hands. Anybody? Couple. Cool. Anybody that didn't raise their hand, please subscribe to my YouTube channel. Yeah, so Bitcoin hash price basically is how much mining is there and how much money is being dished out by the Bitcoin network. And if you divide the two, then you have a number that tells you how much revenue per unit of compute per day does the Bitcoin network pay you. Okay, and at different hash price levels, this translates to 30, 40, 50, 60, $70, I believe. And this is what we would make on a monthly basis, right? So if hash price is 30, we're making 10K a month in revenue. And if hash price is 1100, we're making 23,000 Rand in revenue. Okay. So it depends when you do these projects, right? Again, we want to under promise and over deliver, right? So when you talk about investment in mining or planning these projects, you want to assume that you are going to stay poor for the longest time, and it still works, right? That's how you want to structure these things. All right, cool. So here's the bummer about all this: the project is not live, right? And that's another learning. When I planned this project, I was like, okay, I've come to adopting Bitcoin. I'm going to talk about how this project is live and it's hashing. I'm going to show you live updates and hash rate. Not happening. Okay, why? Because there's no power. Because just before we deployed, their ELC broke and nobody can figure out why. The person who built the site has since deceased, left us to a better place, and nobody knows how to fix it. So there's no power. And now we have to consider alternatives, right? With no power, and also we didn't sign our contracts yet because we're dealing with 6-year-old lawyers who have never heard of the word Bitcoin. And now they need to figure out how do we structure a proper agreement around Bitcoin mining. Good luck. And I can't talk to us because obviously we're part of the conversation, right? So now we're considering alternative sites. We're talking to the farmers about their buddies because that same concept of a dump load has been used 50 times in different projects, right? There's several other projects where they use the same solution. And basically, wherever you see a dump load like the one that I showed you, the oven rods, right? Wherever that exists, Bitcoin mining makes sense. Because wherever they turn electricity into heat, it makes sense to make money instead and then turn it into heat. Right, so what are the key learnings? Number one, close contracts before doing anything. We got very excited and we didn't have patience. Okay. And then make sure power is available. Have more patience before you do this, right? Because anything can happen. Also, I learned South Africa is a very beautiful country in that process. It's in the middle of nowhere. You travel a lot, you know. But at the end of the day, this is what the project really was about, right? Is to find those innovative solutions. And now, you know, bear in mind, we're talking about 12 machines. This is the smallest of projects, right? It's not big at all. Yet these machines make a lot of noise. There's a lot of dust. There's a lot of heat. There's a lot of traveling around. There's a lot of infrastructure to be built. A lot of, you know, taking sand out of the ground to build all of these cable channels for, right? You're dealing with internet infrastructure. You're putting up ladders. You're doing all of this stuff to power 12 machines, right? And now think, what does it mean to install 10,000 of these? Right? It's a whole different ballgame. And again, I hope this showcased somewhat how physical Bitcoin mining really is and what it takes to power these machines. It's real people, it's energy, it's a lot of sweat, a lot of, you know, not so great food on South African farms. So it's a lot of sacrifice as well in order for you just to have machines running. And we're not even talking about keeping them. We're just talking about getting them there and setting them up and connecting them properly. So yeah, look, I talk about mining every week, the whole year. You can follow me on YouTube to learn how mining works more conceptually. I have really started doing expert interviews. Then realized my audience doesn't really follow when I talk about tool shares and strategy tool and encryption, blah, blah, blah. So I try to break some of these concepts down in like 10-minute format. Yeah, that's me. I think I'm way almost 2 minutes. Questions? Go.
Yeah, the turbines.
Yeah.
Is there a turbine option for a flowing river? And like,
Yes.
what's the QMix that you need? And then other side of it, the turbine option that you're using there requires a fall. Right?
Every turbine requires a fall.
Well, I mean, in a river, like
Yeah, fair enough. But they will even the smallest setup will have a minute drop.
And what kind of drop do you need?
It depends on the turbine. You can get very, very small turbines. I don't know, have you ever seen these YouTube videos where they have like these right? Micro hydros where they just power a string of lights. You know, it goes from very small to very, very big.
But is there like a minimum for that kind of, for that 300?
So if you want to power a Bitcoin miner, you need at least 3 kilowatts, 4 kilowatts. So yeah, it needs to have some size. But again, like this hydro that you saw there, you know,
what was the fall there?
Good question. I don't know. I think 5 meters or something. Yeah, from the intake down.
Is solar energy not a viable option?
It is. It is. If you structure it well enough, and if you make the right assumptions. I see a lot of people buying new generation miners, plugging them into solar, and never making their money back. But it's not the right approach because everybody thinks, okay, if I have low uptime throughout the year, now I need the most advanced miner, the most efficient one, so make as much money. But they cost significantly more, out of proportion more. So if you don't use used gear, then you will not be having financial only free. Yeah.
You're using used gear,
Yeah.
you don't actively cool them, and we're recycling them, so they have a lot of thermal stresses and there's dust.
Yeah.
So like, how do they not just die within a couple of months?
Because they're Watts miners, they're not Bitmain machines,
Yeah.
basically. These machines are very reliable. Watts miners, they're built like tanks. There's a funny story by Gridless where they had a container, somebody left the light on, and Kenyan bugs flew into the container. They dimmed out the lights, right? The thick swarm of bugs, they all sucked through the machines. They all got a notification on their phone, say, oh, efficiency is down by so at the same time. The point of the story is the machines were still running. And the next day they were sitting there with toothbrushes, right? And we do filter there. We try to keep the dust out as much as possible. That's probably the most. And then you need cleaning as well, right? I mean, there's going to be daily maintenance. There's daily somebody goes to the sites and opens snow, make sure there's no animals in there. Right? But cleaning is part of that monthly process. Taking the fans off, dusting them off, and stuff like that. One more.
The amount of documentation really controls also actions. So that.
No, that thing that you saw, unfortunately, I can't show you anymore. But that middle picture with that funky, that I call the funky contraptions.
Yeah.
Nobody knows how it's designed because it's all analog. Nowadays, everything is digital. But somebody managed to build this thing in an analog fashion with nothing digital. But then somehow guide the electricity of where to go. Nobody really knows how to fix it. Yeah, it's the end of the story. They don't have any energy today. And I hope next year I can come in and rectify this.
Die Here we saying boer maak 'n plan.
Ja, Engelsman maakt hier maar